Hello, welcome to this little tutorial on hypothesis testing with a geometric distribution. Just a little reminder of the geometric distribution. We've already covered it. There you go. Those are the key cumulative probabilities that we need. Let's look at this example. Clarence, he likes throwing screwed up pieces of paper into the bin. He claims he can throw one at the bin and he will get it in a third of the time. Sam's a bit unsure. He says, well, I challenge you, Clarence, prove it. But Clarence takes 8 attempts, which seems a bit more than it should. Is it enough, though, to doubt him? Clarence takes 8 attempts. So we're going to test it at the 5% significance level. Let's structure the test. We're going to structure it as well as we can. Now, let the random variable x equal the number of throws before Clarence's first success. So we've defined x. I've got a null hypothesis, which is the norm. This is what Clarence says. He thinks he's got a third of the chance to get it in. The alternative hypothesis is that the probability is less than a third. The probability is less than a third. So we actually assume the null hypothesis. So that x is a geometric distribution with a probability a third, because we're talking about the number of throws until he gets one in. So in the little scenario here, we've seen how long it takes. Clarence took 8 throws. That's why we're using a geometric distribution. So we know it's a significance level of 5%. So that's the percentage we're testing against. We need to find the probability that x is greater than or equal to 8. 8 is higher than it should be. We'd be expecting 3, really. We should expect 3. That would be the average. But 8 is a lot more. So we're going to say, well, what's the probability that it's 8, or even more extreme, or even worse than that? How likely is Clarence to get into this area, this region of 8 or above? And we need to say, well, is this 5% or less? Is it that unlikely? Well, that's the same as asking, well, what's the chance of him getting 7 failures, 7 consecutive failures? So it's probability of missing, which is 2/3 to the power 7. And the probability of that, if you do that on the calculator, is 0.0585. That's to 3 significant figures. Well, that is greater than 5%. 0.0585 is greater than 0.05. So, therefore, there is insufficient evidence to reject the null hypothesis. We cannot, according to this statistical model at least, we cannot conclude that Clarence is overstating his chance. Right, let's just review what we've done. I've defined X. So these are all important steps. Define X. Null alternative hypothesis. State your assumption. What model of probability are we using? It's geometric because we've let Clarence throw until he gets one in. It's 8, so we're going to think, well, that's a lot more than you think it would be. So what's the probability of him doing that badly? Well, assuming that there is a third of a chance, it's over 5%. He needs 7 successive failures to do that. And actually, there's above a 5% chance. So if that's the significance level we've set, we can't reject the null hypothesis. And I've put a contextual statement in there. That is everything you need. So when you do one of these, I want to see all of this. Okay, hope it's clear. Thank you.